Now let us see the numerical problem from board book. So all the problems are given in question number 4. Question number 4, 1. I will read the problem. At what distance below the surface of the earth the acceleration due to the gravity decreases by 10% of its value at the surface, given radius of the earth is equal to 6400 kilometer. Answer पण आपल्याला किलोमीटरमध्येच काढायला सांगितलेलं आहे. Okay. So below the surface of the earth means GD is given. So GD is decreases by 10% than earth surface. So on the surface of the earth the value is G, it decreases by 10% of G, and therefore this is equal to 90 times G upon 100. So GD is equal to 0.9 G, R is equal to 6400 kilometer, depth D is equal to question mark. So the formula is like this. Gravitational acceleration at depth D below Earth surface is GD is equal to G into bracket 1 minus depth upon R. So GD is given, substitute. Therefore 0.9 G is equal to G into bracket 1 minus D by R. Therefore G will get cancelled. So 0.9 is equal to 1 minus D by R. Therefore D by R is equal to 1 minus 0.9, that is equal to 0.1. And therefore depth D is equal to 0.1 times capital R. 0.1 times multiplied by 6400 kilometer, that is equal to 640 kilometer. So depth D is equal to 640 kilometer. So at depth D is equal to 640 kilometer, the gravitational acceleration will decrease by 10%. Second problem, question number 4, 2. If the earth were made of wood, the mass of the wooden earth would have been 10% as much as it is now, without changing its diameter. Calculate the escape speed from this earth. The escape speed ची व्हॅल्यू आपल्याला वुडन अर्थ साठी विचारली, मास मध्ये चेंज केलेला आहे. सो we will give the quantity with symbol like this. Mass of wooden earth MW is equal to 1/10 of mass of the earth. ये क्वांटिटी झाली. रेडियस ऑफ द अर्थ, डायमीटर सारखा म्हणजे रेडियस पण सारखा. रेडियस ऑफ द वुडन अर्थ RW is equal to radius of the earth. Escape velocity V from the surface of wooden earth is equal to question mark. And we know the escape velocity from the surface of the earth, it is constant 11.2 किलोमीटर पर सेकंड. ही व्हॅल्यू आपल्याला दिलेली ही आपण डायरेक्ट यूज करू शकतो. प्रॉब्लेम दोन मेथडने सॉल्व्ह करता येऊ शकतो आपल्याला. सो द फॉर्म्युला फॉर द escape velocity from the surface of planet is like this. VE is equal to VEW is equal to escape velocity from the surface of wooden earth, and therefore VEW is equal to under root 2 times G MW upon RW. This is equation 1. So better way we will give the equation like this. So this is equal to root 2 multiplied by G, MW is replaced by ME by 10 upon RW. So this is equal to 1 upon root of 10 multiplied by root 2 times G mass of the earth upon radius of the earth. This RW is equal to this much. So this is equation 1. But in equation 1, root 2 times G ME upon RE is equal to V is equal to escape velocity from earth, and this is equal to V is equal to 11.2 kilometer per second. Therefore this is equation 2. Put 2 in 1, therefore VEW is equal to 1 upon root 10 multiplied by escape velocity from the earth. So that is equal to 11.2 kilometer per second upon root of 10 is 3162. So this escape velocity from the surface of the wooden earth is, it will be nearly between 3 and 4. So I will give the answer directly. 3.54 kilometer per second. Kilometer per second, like this. So we have used this value directly. Second method is substitute all the values inside the bracket. 2 multiplied by 6.67 into 10 into minus 11. Mass of the earth is 6 into 10 into 24, etc. तर त्या व्हॅल्यू जर आपल्याला दिल्या असतील तर आपण त्या मेथडने पण जाऊ शकतो. आन्सर हेच आहे. नेक्स्ट क्वेश्चन नंबर 4.3. प्रॉब्लेम स्टार्ट होने. Calculate the kinetic energy, potential energy, total energy and binding energy of an artificial satellite of mass 2000 kg orbiting at a height of 3600 km above the surface of the earth. G is given, R is given, mass of the earth is given. So all the quantities are given. So we will give the data like this. So mass of the artificial satellite, it is denoted by M. So M is equal to 2000 kilogram is equal to 2 into 10 to 3 kilogram. Mass of the satellite. Capital M is equal to 6 into 10 to 24. Earth mass is kilogram. Mass of the earth. Capital R is equal to kilometer के लिए 6.4 into 10 to 6 meter is equal to radius of the earth. Radius of the earth. Capital G is equal to universal constant 6.67 into 10 to minus 11 Newton meter square per kg square. So these are the quantity given, and now you have to find height is given 36, height h is equal to 3600 kilometer is equal to 3.6 into 10 to 6 meter. K पहिला part question mark. Then next quantity is the P, T, and B. एवढा क्वांटिटी आपल्याला कॉम्प्युट करायचं आहे. So we will complete first part. For an orbiting satellite, K is equal to 1/2 mvc square, where Vc is equal to under root gm upon small r is equal to critical velocity. Therefore, Vc square is equal to gm upon small r is equal to gm upon small r is replaced by r plus h, and therefore kinetic energy becomes 1/2 m gm upon r plus h. So this is equal to फॉर्म्युला आपल्याला या ऑर्डर मध्ये लक्षात ठेवण्याची सवय आहे, gmm upon r plus h. So substitute 1/2 multiplied by 6.67 into 10 to minus 11 multiplied by 6.67 into 10 to minus 11 multiplied by 6 into 10 to 24 mass of the earth multiplied by 2 into 10 to 3 upon 2 multiplied by 6.4 into 10 to 6 plus 3.6 into 10 to 6 like this. And therefore kinetic energy is equal to 2 cancel झाला. So 6.67 multiplied by 6 and over the power 24 minus 11, so 13 plus 3 10 to 16 upon this 2 already cancelled, so this is 6.4 plus 3.6 into 10 to 6 common. So this is the product is 14.204. So 14.2 into 10 raised to 6 into 10 raised to minus 6 upon 10. So 4.002. This 10 raised to plus 6 minus 6 will get 10. Sorry, this is 16. So 10 raised to 10 joule. So this is the value of kinetic energy. So it is given in the power of 10. So kinetic energy is equal to 14.02 into 10 raised to 9 joule. This is the first answer. Now, in the second, third, and fourth part, we have to find P, D, and therefore, we will use this important relation. So, why we have made star? This is the reason. For an orbiting satellite, we know this relation. Relation between the four energy. Kinetic energy is always positive. Binding energy is always positive. Total energy is negative because of force of attraction. Potential energy is negative. So plus plus minus minus and only this is by 2. So remember this equation. So once we know any one of the four energy, we can find the remaining energy. So we know kinetic energy, we can find potential energy. So second part. The relation between K and P is like this. Minus P by 2 is equal to K. Therefore, P is equal to minus 2 times K. Minus 2 multiplied by 14.02 into 10 raised to 9. So that is equal to minus 80.04 into 10 raised to 9 joule. And therefore, P is equal to negative the ILS by G 80.04 into 10 raised to 9 joule. This is the second part. Now third part, we have to find total energy. आता K and total energy मधला relation दिला. Third part. Minus P is equal to K. K relation use केला आपण. Therefore, total energy is equal to minus K is equal to minus 14.02 into 10 raised to 9 joule. And therefore, the total energy of the orbiting satellite is equal to minus 14.02 into 10 raised to 9 joule. This is the third answer. And now we have to find last binding energy. B is equal to K is equal to 14.02 into 10 raised to 9 joule. K and P are equal. So these are the three answers. So for orbiting satellite, we know this equation. So we can use this equation directly. So remember this relation, K is equal to B is equal to minus T is equal to minus P by 2. For orbiting satellite, this is the equation between the four types of energy associated with the orbital motion of the satellite. Next problem. Question number 4. Two satellites A and B are revolving around a planet. Their period of revolution are 1 hour and 8 hours respectively. The radius of the orbit of the satellite B is 4 into 10 to 4 kilometer. Find the radius of the satellite A. So logically we can give the answer. T square is directly proportional to r cube. So period of A satellite is less, therefore its radius will also be less. So answer will be less than 4 into 10 to 4 kilometer. MCQ मध्ये पण असे प्रॉब्लेम विचारले असतात तेव्हा आपल्याला लॉजिकली सांगता यायला पाहिजे लक्षात. सो व्हॉट इज द गिवन क्वांटिटी? TA and TB are given. TA is equal to 1 hour. TB is equal to 8 hours. RA is equal to question mark. RB is equal to 4 into 10 to 4 kilometer. So we require the relation between the period and radius of the circular orbit, and that relation is the Kepler's law. T square directly proportional to r cube. So we can use that relation directly. So period of revolution capital T is equal to 2 pi multiplied by under root r cube upon gm. Therefore T square is equal to 4 pi square gm, 4 pi square upon gm into r cube, that is equal to a r cube, equation 1, where k is equal to 4 pi square upon gm is equal to constant, and therefore using equation 1 you can use like this. So Ta square upon Tb square is equal to k times Ra cube, k times Rb cube. So this kk will get cancelled. So Ta upon Tb whole bracket square is equal to Ra upon Rb whole bracket cube. आपण डायरेक्ट इथून सुरुवात केली तरी चालेल. So substitute 1 upon 8 bracket square is equal to Ra upon Rb bracket cube. Therefore I will change the sign. Ra upon Rb cube is equal to 1 upon 64. Therefore Ra upon Rb is equal to cube root of 1 upon 64, that is equal to 1 by 4, and therefore Ra is equal to Rb by 4. So 4 into 10 to 4, value of Rb divided by 4, 4 will get cancelled. So Ra is equal to radius of आपल्याला काय लँग्वेज मध्ये आन्सर विचारलेलं आहे. फाइंड द radius of the orbit of satellite A. Radius of the orbit of satellite A is equal to Ra is equal to 1 into 10 to 4 kilometer. This answer is in kilometer. One into 10 to 4 kilometer, like this. So let us see the next problem. Question number 4-5. Find the gravitational force between the sun and the earth. Given mass of the sun is equal to 1.99 into 10 to 30. Mass of the earth is equal to 5.98 into 10 to 24. Average distance between the earth and the sun is equal to 1.5 into 10 to 11. So it is a substitution type problem. Only we have to use the gravitational force, formula for gravitational force. So I will give directly that formula. F is equal to gravitational force of attraction between Sun and Earth, and therefore F is equal to G m1 m2. m1 is the mass of the Sun, m2 is the mass of the Earth upon distance between them. So this is equal to 6.67 into 10 raised to minus 11 multiplied by 1.99 into 10 raised to 30 kilogram multiplied by 5.98 into 10 raised to 24 upon 1.5 into 10 raised to 11. Distance between them is in meter, 10 raised to 11. Again 1.5 into 10 raised to 11. So this is equal to. So for rough calculation, I will round up this as a 2, this is as a 6. So approximately you can calculate the answer levels. 6.67 into 2 into 6 into total power of 10 is 30 plus 24, 54. 54 minus 11, 43. Upon this 1.5 into 1.5, this is equal to 2.25 into 10 into 22. So this is equal to 6.67 into R. I will multiply by this 2. 13.34 into 6, and this 2.25 can be written as 9 by 4 into 10 raised to 43 into 10 raised to minus 22. So this 4 will go up. So 4 multiplied by 13.34 multiplied by this will be 2 by 3. This is 6, this is 9. So divide by 3. This is 10 raised to 21. So make the rough calculation. So 8 multiplied by 4 into 8, and this 3 will divide here. So 4, 4, 4, 7 into 10 raised to 21. And therefore the force is equal to 56, 37, 35, 35. So 35.57 equal answer. Into 10 raised to 21 Newton. Force is measured in Newton. So answer will be 3.55. Therefore force F is equal to 3.558 into 10 raised to 22 Newton. The force of attraction between the Sun and the Earth is this much. Next, question number 4, 6. Question number 4, 6. Calculate the acceleration due to the gravity at height of 300 km from the surface of the Earth. M is given, R is given. So height h is the important factor. Height h is equal to 300 kilometer. Then GH करण्याच्या दोन मेथड आहे. इथे गिवन क्वांटिटी काय त्याप्रमाणे आपल्याला फॉर्म्युला बदलावा लागेल. सो m is equal to mass of the earth 5.98 into 10 to 24 kilogram. R is equal to, I will directly convert it, so 6,400 kilometer, and we are to find G at height h. So this is one formula. G h is equal to G into bracket R upon R plus h whole bracket square. But we cannot use this formula because G is not given. But we use the value of M, mass of the earth, and therefore at height h, the value of Gh is given by at height h, gravitational acceleration Gh is equal to Gh is given by Gm is equal to Gh into small r square, Gh into r plus h whole bracket square. Small r is equal to r plus h, and therefore the formula for Gh is equal to G universal constant M mass of the earth divided by r plus h whole bracket square. Substitute. So 6.67 into 10 to minus 11, 5.98 into 10 to 24 upon, this is equal to R is equal to 6,400 kilometer into 10 to 3 plus 3 into 300 into 10 to 3 bracket square. So substitute, this is nearly 6. Upon approximate calculation, so this is equal to 4 bracket square. So 6.67. So I will multiply this. So 40.02 into 10 to 13 upon 6.7 into 10 to 6 whole bracket square. So 14.02 into 10 to 13, 6.7, again 6.7 into 10 to 12. So 14.02 into 10 upon 6.7 multiplied by 6.7. So 400.2 upon 6.7. त्याचा डायरेक्ट आपण स्क्वेअर बोललो. पॉवर टेबल आपल्या याच्यात दिलेला आहे 6.7. So 6.7 has square 44.89. 44.89. So if it is 40, then answer will be nearly 10. So answer is less than 10. So I think answer will be something 8 point something. 9.8 पेक्षा तर कमी देईल. So answer is 8.889 meter per second square. So gravitational acceleration at given height h is equal to this much, like this. So in this problem, question number 4, we have used the Kepler's law. T square directly proportional to r cube. हे relation आपण directly use केलं तरी चालू शकेल. लक्षात. So we will see the remaining problem in next session. Okay, we will stop here.